So today we are going to start some important topics today. So we'll start. So like previously we had missed one of the very important topic, which is Kubernetes probes actually, right? So we'll start with that actually, though it's a small topic and we could have covered at the very beginning itself, but I mean we missed it out somehow. But okay, that is fine. Uh, so today's day 18, right? So we'll be having these two topics, right? So probes, it's a very small topic we'll be covering today, and as well as we'll start with the introduction to the Helm actually. So what is Helm and why we are using Helm and all we will discuss today. Okay. So now, what is basically a probe actually? Probe is is a health check which that can be configured to to check the health of the container running in the pod. It's basically whenever you want to check the health of the container, whether the container is running or not, whether the container is ready to, receive any kind of a request or not, right? For example, in your container, right, some kind of a Tomcat, no Tomcat application is running, right? So whenever you want to access that application, right, so you need to basically provide an IP address and provide a particular port number to access it, or else if you have some kind of a domain URL, right? You need to hit that URL to access the application which is running inside your inside your pod, right? So what happened, right? Whenever you are accessing the application, right, the application should be ready to give a service to the end user, right? Suppose assume that there is some reason, even though your application is running inside a pod or inside a container, so due to some reason, the application might not provide or the container might not provide the service to the end user. There could be various reasons, right? Maybe like the application which is running inside the container or within a pod, right? That might lot of excessive threats might have created, or a lot of hog might created, or there might not be a sufficient disk space, or there might not be a sufficient memory to execute any task. So in that case, what happened, right? Even though if you see the pod is running, okay, if you say kubectl get pods, you could see that your pod is running, so you will understand that okay, my application is running inside a pod, so that is working fine. But if you try to access that application which is actually running in the container or within a pod, that might not give the service. Okay, so to know better about that, actually we have something as a probes actually. Okay, so probes is nothing but it's a health check that can be configured to check the health of the container running in a pod. So a probe may return the following results, sir. Always, whenever you have specified a probe, always a probe may return the following results. What are those results? It might always say success. It means that it specify that your pod is running fine or the health is fine, or it might return a failure, or else it can even specify some unknown. So these are the three written values of the probe actually. So whenever you have configured the probe, whenever the probes are working fine, it always returns success. Whenever the probe fails, actually it returns a failure. And whenever it does, apart from the success and failure, there is one more state, a result known as a unknown state actually. So these are the three return values actually. Okay. So there are two types of probes are actually. What are those two types of probes? One is a liveness probe and other is a readiness probe actually. Okay, liveness probe and readiness probe. What is liveness probe actually? Basically, liveness probe is how we can say that this probe, this liveness probe, is used to is used to determine if the particular container is running or not. If the particular container is running or not. So assume that you are running a container or there is a container within the pod actually. You need to check if that particular container is running or not. Okay. So in that case, actually, you can check with the help of a Liveness probe. So this probe is used to determine if the particular container is running or not. If the container fails, if a container fails the liveness probe, if the container fails the liveness probe, then the controller, which control means the will Kubernetes controller will try to restart the pod in the same node. It means that assume that actually what is happening that if your container fails actually, it means that actually your pod fails. So whatever the containers which is running within a pod, if the pod fails, it means that your container is not running. So then what is happening that your controller is not but your Kubernetes controller. Then your controller, it is not but the Kubernetes controller will try to restart the pod in the same node. So this is by default, sir. Like in Kubernetes, what happened, right? By default, what happened whenever any container fails, actually, what is happening that the Kubernetes controller will always try to restart that particular pod in the same node. It is all based on restart policy. So there are some restart policies are there based on the restart policy. So the controller will take a decision, but always a default restart policy. The default restart policy is the restart policy is always. So there are three types of policies or restart policy. One is always, and other is a never. Okay, never is what it means that actually you don't want to restart the pod. So you can set the restart policy as never. Okay, there is one more restart policy known as a failure. So there are three types of restart policies are there: always, never, and failure. Okay, so those we will discuss later. But what he is trying to say that here in liveness probe means this is used to determine if the particular container is running or not. So you need to check if the particular container is running or not. If the particular container is not running, by default, what happened, right? The controller will restart the policy. Always, even you can explicitly specify the restart policy as always. It means that once the container fails, automatically it gets restart into the same node. So this is one kind of a probe actually. The second kind of a probe is nothing but readiness. So this probe, in this probe, it means the readiness probe, it is used to determine whether a particular container is receive the request, ready to receive the request or not. If this fails, then the Kubernetes controller, if this fails, then Kubernetes controller will ensure the pod doesn't receive any request. It means that what it means, if a particular container is running within a pod, and if that pod, if you have set a readiness probe for that, what is readiness probe means? If the particular container which is running within a pod, if it receives any request, suppose that what happened, it is always exposing some application. It means that you, whenever you want to access an application, you basically hit a URL, correct? Now what happened, right? That container which is running within a pod, it will be keep giving the service. Assume that at certain point of time it will stop giving the service. It means that the pod has gone busy. It has, due to some reason. Okay, that's what I said earlier. Based on the like hardware constraint, right? The pod might not be able to suffice the need for any kind of a user request for that running container. In that case, what is happening is that if you have set the readiness probe, actually, what happened? The controller will check if the container is ready to give the request or not. If not, what will do that? The controller, it means that the Kubernetes controller will ensure that pod doesn't receive any more requests. It means that actually, whenever the request comes, the controller knows that okay, this pod is not able to suffice any request, so the request will not get into that pod actually. So what it will do, whatever the request is coming, it will try to redirect to some other pod where no some other containers are actively running. So that is what it is used to. So these are basically two types of probes are actually liveness probe and readiness probe. So if a container specifies a readiness probe, its default state will be failure until the readiness probe succeeds, we say. So it means that actually, so whenever the readiness probes get failed in any of the running container, what happened? The Kubernetes will ensure that the pod doesn't receive any request to it. It will not read it or it will not send any request to that particular pod. Okay, so these are the two probes what we are having, and we will be having a examples on these two pod itself are actually. Okay, now what is an implementation of the pods are actually like when you're implementing, how you implement in the pods actually. Basically what happened, if you see the YAML file, you will better understand. Like basically in both of this liveness probe and readiness probe, there are two types of probes are there. So one is a command probe and other is something like a HTTP request probe actually. So what is the next one? Implementation of the props. Implementation of the props. So basically there are two types of, one is a command probe. This is what the most user always we use most of the time, the command probes actually. The second is what HTTP request probes actually. So here what is happening that here you are checking what you are doing here in this probe. What will do happen? The control will get the what happened? How I should say means in this probe, the controller will get the container to execute a specific command. So what it says that here, how I can write in this probe, controller, it is the Kubernetes controller will get the container to execute a specific command, sir. Specific command in order to perform the probe in the container. That's what we say. So here what happened, right? You will specify some kind of a command, sir. Like for example, some particular command is executing. So it states that actually, what is it states that your container is running actually. If particular command execution get fails actually, it means that if it is not executing a particular command, then what is happening that you will come to conclusion saying that the container is not running or the pod is not running. That's how we say. Okay. So whenever any running pod, you we always say that always by default what happened, right? The pod, whichever the pod which has got created, right, sir, that should keep executing some particular job actually. Then you say that the pod is actually up and running. Then that's what when you execute the kubectl get pod, right, you will get the you'll get the pod status as a running state, right? If suppose how you say it's running state, you'll come to the conclusion that actually yes, the pod is executing some task or basically it is executing some command actually. So what is happening that in this probes actually, okay, liveness probe and readiness probe, you can implement the probes with the help of these two methods. One is a command probe and another is a HTTP request probe. Command probe is something like you say that actually a particular container is executing a specific command in order to perform the probe in the container. What is HTTP probe? HTTP probe is something like in this probe. So I can say in this probe, controller will send kind of a get HTTP request to the given address. Like to the given address means to either to something like a port number or to the particular port or to some IP address or to some host name. Like that, it will always send some kind of a get request to a particular port or to particular host to perform the probe. Actually, we say to perform the probe on a container. We can uh, we can set the even we can even set some other different probes also. Following probes. or following fields. When it comes to HTTP request probe, right, we can even set the following fields actually to configure the HTTP probe. Except, for example, that's what I said. Like you can mention like, okay, you are doing a probe either to some port number, some port number. You specify the port number. You say that okay, always do a probe to the port, some particular specific port number. Even you can specify. Sorry, what happened today? You can even set to some host name actually. Okay. Even you can set to some HTTP headers like that. You can even set to some kind of a TCP socket probe also. Socket probe. So these are the different, fields to configure the HTTP probes are actually. So this is also most of the time this is also used, but we always know the recommended is always to go with the command probe because it is very easy to configure. HTTP request probe also is good actually, but whereas when you are having a particular some kind of a service is provided by your container, like for example when it is providing some URL service or something like, you can actually implement the HTTP probe in that case. Like for example, many of the sites, right? You might be having something like you are having a website, something like rajeshsingh.com slash home, right? So what you mentioned that it means that it is a home page of your of your main site actually, right? Same thing you have rajeshsingh.com/inventories actually. So basically you want to check the inventories actually, what are the things which are there in your inventories, or how many things are left, how many stocks are available, or how many have been sold or left out, like that you maintain inventory. So basically what happened, right, you will be monitoring this like the complete path here actually. You can even specify the path also, port number, host number, as well as I have not mentioned here, even you can set with the path also. So by providing this path, actually, you are monitoring whether this path of the URL, right, it is receiving that request or not. If it is not receiving, somehow this complete URL is down. Actually, here what happened? The probe we are set for the inventories, but ultimately what happened? The inventory is this site, right? This path, right, might not be responding. In that case, what happened is this HTTP request will fail actually. So what is happening if this prop get failed actually, what the controller will conclude that basically, right, the application which is running inside that pod, right, it is not running. Okay, in that way it will conclude. So both the ways, sir, command probe as well as HTTP probe, you can you can implement the probes for both for liveness and readiness probe. Clear, sir? Any doubts you have, sir, here? Because this is a very simple thing what we have tried to understand. Okay.
No,
Okay. So, see, each and every probe, sir, it has to do a lot with the restart policy, sir, basically. So, restart policy, I already discussed, right? So, we can specify the restart policy in a pod spec, sir, to instruct the controller about the condition to restart the pod, actually. So, you know very well that in liveness probe, if the pod gets fails, so this liveness probe will specify whether the container is running or not. Whereas readiness probe, see, you have to tell if they ask you what is the difference with the liveness probe and readiness probe, you have to say, sir, liveness probe is not, but it is used to determine whether a particular container is running or not. That's all. We are not specifying whether inside the container how the application is running. We are not worried about that. We are only specifying whether the container is running or not, right? And as you know, if the container is has failed and it means that it has stopped or it has terminated, right? By default, what happened, right? Your controller will try to restart the same pod in the same node. It is based on all your restart policy. But whereas a readiness probe, it is used to determine whether the particular container is ready to receive the request or not. So indirectly, you can say that whether the particular application inside the container is running or not. To check that one, we have a readiness probe. Okay. So as I said, right, the probes can do, can has a lot to do with the restart policy. As I said. So we can specify the restart policy in a pod specification. Like when you are writing a YAML file, right, you specify the restart policy to instruct the controller about the condition to restart the pod. The default value of the restart policy is always, that's what I said, right? It is always restart, right? And the possible values are always, so for the restart, policies. There are three types actually. One is always, always. So always means what, sir? Always means always restart the pod whenever it terminates. Right? Whenever the pod get terminates, restart it always. Second is on failure or failure, I said. And the third is never. So these are the three restart policies, and we will see how to use these restart policies when we are writing a YAML file. Actually. Okay. Now we will see an example of how we can implement the liveness probe, sir. So to have that actually basically, so I have some examples over here. You could see that actually I have a liveness probe implemented in my YAML file or in my manifest file actually. Now you could see that actually I am specifying the kind as a pod here. In the metadata, you are just mentioning the pod name. So liveness probe always restart. It means that basically you want to always restart it. Now you could see that under the metadata, you have something also restart policy. All this is we have not seen it. We are seeing it today itself, right? So this is one of the field or which is one of the member within the metadata itself, sir. And here you are mentioning is the always. It means that whatever the container, if it fails, the restart policy will say that, okay, please restart that container again. So your Kubernetes controller will restart the pod again. Okay. Now here what is happening that you are having a container. Within a container, you are using a Ubuntu image. So Ubuntu latest I'm using. And here what is happening that you are specifying the command. So basically what happened, as soon as this Ubuntu image gets created or get initialized, what you're doing immediately, you're actually running a command here. So what you're doing here, basically you are calling a bash and you're passing some -e option to the bash shell. And for this bash, you're giving, you are executing a command. What command you're executing? You are using a touch command to create a file. Under temp, you're trying to create a Rajesh file and you'll sleep for 30 seconds. After 30 seconds expired, you are trying to remove the same file, Rajesh, and again sleep for 600 seconds. So 600 seconds is almost how much? 10 minutes, 10 minutes, right? So what we are trying to do that actually basically here you are executing some series of commands here actually. This is very simple example to just to showcase that how exactly liveness probe works actually. And within the container actually you have a name, you have an image, you have a command, as well as you have something which is a liveness probe actually. If you see the our cheat sheet, right? If you go to the official Kubernetes website, and if you if you check for or if you search for the what are the fields which are there within a container for the pod, right? You could see that there is something as a liveness probe, sir. Attend the liveness probe here. You are calling an exec and you're calling a command. And here what you're doing a cat to cat. That means that you are actually reading the content of this temp file under a Rajesh file under the temp. You're trying to just read it. And here what is happening that you need to set the initial delay seconds of 5 seconds. It means that until 5 seconds, the probe will not work. Once the 5 seconds happens, the liveness probe will start looking into it. So now what is happening is that every 5 seconds it will try to check it actually. This is the periodic second. Every 5 seconds it's going to check for the probes whether what is the status of this command. So what this command is doing under the liveness probe, you're trying to do a cat to this file. Now you could see that actually you have created a file, fine. Now when you do a cat command to this file, even though it is empty file, so this command is getting executed, sir. But what you're doing here in the command mode here within the container, you have created the file, Rajesh, and then what is happening? You're making it to sleep for 30 seconds. So what happened? It will wait for 30 seconds. Meanwhile, by that time, what is happening that the initial delay seconds will get expired. So it means that what your initial delay second means after 5 seconds, okay, check for the probes, check for the liveness probe. So this liveness probe, what it will do, it will try to execute this command. What is the command? You're trying to read this file. Okay, cat/temp/Rajesh. Oh, okay, this file is there. So till how much will be there? Till the next 25 seconds, it will be keep doing because you are meant for sleep for 30 seconds, right? So once after the 30-second expires, right, you will see what you're doing next command. You're removing this file, rm command. You're removing this file. Now after that, what is happening that what is happening within again after 5 seconds, what is happening that it will try to run this command. So once it runs this command, what happened that it says that this command has failed now because there is no file because you already removed now. But again after removing you went for the sleep for 600 seconds. Now, by that time, what is happening that because of the periodic second, after 5 seconds, it will again try to check the for the liveness probe, and it will try to execute this command. When it executing the command, it's going to check this file is not there. Then what is happening that the liveness probe will get failed actually, right? It get failed. Now you know that according to the restart policy, if it is getting failed, it means that what is happening, the container will restart it. The container will restart means it means that the pod will get restarted. So according to this policy, the pod will get restarted. Again, you could see that the pod is going to start running from the beginning again. So this is what to just to check or verify that how exactly liveness probe works actually. Okay. Now what I will do, I'll just try to copy this file, YAML file or a manifest file. I'll just copy this file. So I have a master over here. I'll just say kubectl get pods. Just check whether there's no pods running. Kubectl get nodes. We'll check whether all the nodes are in active state. Yes, they are ready and they are in active state. Right now, I'll say what is the command? Liveness always restart. Liveness always restart dot YAML. So here this is a file, and then like I'll save it. So I'll say kubectl apply an F and specify the liveness. Okay, choose either restart policy. What is error, sir? Known field restart policy. You choose to ignore this turn validation off. Restart policy correct always. Correct only. So whether this is aligned, check here. So I need to just verify, sir. This one, it is always should be aligned with this exec, sir. So this will part of the exec, fine. This is correct, and then liveness pro is correct. When it get aligned with the command, okay, this is fine. Containers is fine. Restart policy is always okay. Is a lowercase or uppercase? I don't know. I have to think that. Hope that it is that policy. If you choose to ignore this, turn validation off with the validation false. Error validating container. Unknown field containers. Okay. Let's check, sir. I have another example of no restart actually. Never. Okay, sir. I'm sorry. Actually, what happened? It doesn't come in metadata. It comes under the spec actually, sir. This is the mistake I did. So what is happening over here is that actually I think some mistake is there, sir, in the program actually. Here, what is happening is that here we are having a spec. See, you have missed a spec over here actually, right? Liveness probe. Under that, what you have to do? You have to do spec actually. It is missing, sir, actually. Right? So now what we are doing here? So we have missed the spec actually. Oh, if you do it now, what will happen? That if you say kubectl get pods, so you could see that it is running fine. Now, if you execute kubectl describe pod and specify this liveness probe, now you could see that the pod has been started, it is running, but that is fine. Now you could see after like after the 30 seconds, right? Now you just check what will happen actually. Kubectl get pods. Now you could see that after 30 seconds, what will happen that the probe will work and Liveness Probe will do, and then it fails it because of the Liveness Probe has got failed because it is trying to check for the file. Again, it will try to restart it actually. Now you could see that it gives you the how many number of time your pod has got restart actually. So it gets restarted, like you will see the value now. So it means that basically what you're doing that based on the restart policy here, you are making your pod to get restarted once the probe will get failed. So that's what we are trying to check over here. Okay, sir. Same thing here in this example, in the next example, here what we are having that actually no restart actually. So what you're doing that here restart policy, it's the same YAML file, the same stuff over here. But here what you are saying never. It means that the pod should not get restarted actually. Here you're explicitly mentioning that restart policy should be never. But by default, as I said, it is always actually. Correct. So here this also you can run it, you can check it out. So this is what also you are actually managing the Liveness Probe actually. So what happened? See, it restarted now again. So now again, if you try to check what happened, if you try to describe the pod, here you'll get some information, sir. You could see that successfully pull the image, fine, this is all fine. Now what is happening is that, see, it is actually doing a Liveness Probe. It is trying to do a cat of that file Rajesh, but since you have removed the file, no such file, okay, now you could, it is a unhealthy, right? So it says that the reason is unhealthy. So it means that your Liveness Probe has failed actually. That's the reason it will be the unhealthy. Now again, what is happening is it has try to restart it. See, the container Ubuntu failed Liveness Probe, but will be restarted again. So it is killing the pod and again it is restarting, sir. So in this way, you can exactly come to know that how exactly Liveness Probe is working. Right. Similarly, the same stuff, I will not be executing this example, but you can see that instead of restart policy, always you can change it to never actually. Okay. In that case, what happened, right? The pod will not never get restarted at all. It get failed actually. So the pod will come to a failure state. Even if you want, you can even check that also. kubectl. Now you could see that again if I execute kubectl get pods, you could see that actually it has restarted twice again. Okay, one more time because again the same stuff. Okay, again it has failed and it has restarted. So like this way, what is happening is that actually through the describe you can see the events actually, right? Same thing if you execute the kubectl delete if an f and what is it liveness probe always restart. So deleting the pod now, right? Okay. It is taking so much. It'll get pods. It is getting terminated. Yeah, it'll go off. Okay, fine. That's fine. It'll go off. Yeah, now it has gone. It has took time, but it has gone. It'll get pods. Now it is not done. Okay, sir. Liveness without restart .sh.ym. Yeah. Same, sir. Nothing. kubectl apply -f liveness without restarting. So not restarting it. Now you could make out very clearly that it will fail actually. The content will fail. It will not get restarted after some time. Right? You can run a watch command. Now, when it comes to the readiness probe, basically, in the readiness probe, you have an example over here, sir. You have a readiness probe. So what we are doing here in the readiness probe also, here also the same stuff. Either you can implement the command method in the readiness probe, as well as you can even implement the HTTP request probe method. That's all. These two methods you can implement. Either command, this command and HTTP, it is applicable for both, sir. Liveness probe as readiness probe. Even the readiness liveness probe also you can implement the HTTP request probe actually. But here what is happening is that here in the readiness probe also I'm doing the same stuff. The same stuff here. Instead of liveness probe, I'm using a readiness probe. So readiness probe will check or verify whether your application is running or not. Okay. If you here, what is happening in case of a readiness probe, if this command fails, okay, if this command fails, basically after the time expired, after the 30 second, this command will fail. Correct. In the readiness probe also, it is going to check, it's going to do a probe of it. But here in this case, what will happen that the the application will be still will be running, but it will stop. It will stop to receive any more further requests. It means that the control will make sure that any request is coming to your your content, right, that will get stopped when it comes to readiness probe. That's what we discussed here, right? Readiness probe and liveness probe. This will only specify your content is running or not. This will specify whether your application is running or not, or whether your application is ready to receive the request or not. So here also, if you try to execute this YAML file, right, you will see that actually, even though the container is running, but what happened? This probe has failed. It doesn't mean that the container stopped. The container will be running only. It means that the pod will be running, but you will see that actually your pod will never, or it will not receive any further request, because the controller has stopped it actually, the Kubernetes controller, right? So here you could see that actually, see your pod has gone to the error state, right? Because what happened, you have made it as a no restart policy, right? So if you do a kubectl get pods, now you could see that it has gone to the error. We can just say kubectl describe pod and specify this pod name. So just to see the event, see here. Now what it says that is basically, so the liveness probe has failed, no such file directory, stopping the container Ubuntu controller. And after that, actually, through some statement as a failed mount, actually reason, it is saying that actually the particular mount point or something has failed onto this KPI object, like that. It is saying actually, basically. So due to which, what is happening that your pod is not getting restarted, it comes to the error state. So this is a clear way of understanding. If there is no restart policy, obviously your pod will get to the error state, or it will go into the terminate state. Okay. kubectl delete -f liveness without restart. So I'll remove it. So similarly, what we are having readiness probe actually. Readiness probe. What? Yeah. Or it is a readiness command probe actually. Okay, it means that I'm using a command mode itself. Command probe. Same example, sir. The same thing. Instead of liveness probe, I'm using readiness probe. So here, what is happening that now you can make out that if I execute the kubectl apply -f readiness probe. Now you could see that actually that your pod will not go to the fail state. Oh, it has gone to the crash loop back actually. But okay, why it has gone to the crash loop? kubectl get pods. kubectl describe pod. Let's see for the readiness probe. Oh, again it has started. Okay, but kubectl, it will not get restarted. kubectl get pods. It will not. Again, it has gone to the crash backlog. Okay, it has restarted, sir. It has restarted based on, I think, based on the restart policy. It has restarted again. But the point here is that actually, when it is trying to check the readiness probe, right, it is actually failing over here. That's the reason it is going to the crash loopback. Actually, this is one of the status actually. So kubectl describe again pod and specify the readiness probe. Okay, again it is getting restarted. It is getting started. Yeah. Sir, when it comes to the real time, right, actually, basically, most of the time, what we'll do, right, we will basically implement the liveness probe, actually, not the readiness probe. Readiness probe is basically used for probing. For example, you want to get the load balancer, service for your deployment. Under that case, what happened that you will implement the readiness probe. Or else, most of the time, the liveness probe is what which is most used, probing method when it comes to the container actually. So there we are checking if the container is running or not. That's what the most use actually. Okay. Here, basically, again after this readiness probe, actually the same thing you need to implement the HTTP request mode actually. So here you have HTTP liveness, right? Now what you are doing that here you are using the liveness probe only, but instead of command mode you are using the HTTP mode actually. What is HTTP mode or HTTP request mode means? Here you are basically HTTP get request, and what you're doing that you are actually checking whether this particular port is available or not. If the particular port is available, what it is doing, right, it is trying to check whether the slash path is able to access. If it is able to access, then what is happening that the liveness probe will get succeeded. It means that okay, this is available. If not, if the slash is not working, it means that whatever the application site we have, right, like for example, if you have configured, see here in this case you have configured the HTTP, what is happening that HTTP will basically it will be under slash usr usr share http.conf. It means that basically you have implemented the HTTP server you have configured it. But basically what you're doing that the HTTP basically starts from slash usr share httpd, correct? So it means that HTTP daemon or will be running under slash usr share http, but you are not giving the complete path, you are giving from the only from the slash itself actually. So what this liveness probe will do, so it will try to always check from the port number 80, and it is checking whether this path is available or not. So if path is available means basically try to check the slash usr HTTP itself. So every 10 seconds, right, it will be keep checking it. Assume that the HTTP got failed actually. So what happened? The HTTP will not be available if the service got failed, right? HTTP will not be available from the slash path itself. So in that case, what happened? The liveness for checking for the HTTP get probe will get failed. In that case, what happened? The liveness will throw error saying that actually this HTTP get is not working. Otherwise, it will be keep working actually. This is just to showcase a simple example like how exactly with the help of the liveness probe you can even do a probe of your HTTP request also. That is what this example says. So this also you can run. Okay, what is it? Kubectl get what's it? Again, go to the crash box itself. Okay, kubectl delete minus f kubectl or else no. Okay, live HTTP probe. .yaml. So what happened here? What happened, right? This will be keep running, sir. I mean, you will not be able to identify whether it is working or not because unless and until it fails, right, you will not get to know whether this probe is working or not. So it will be keep working actually. If you can ignore turn on the validation, what I did, sir. Spec honey, error we are getting. This probe initial delay settings unknown field. Unknown field, huh? Uh, this one, wait. It comes to exact correct. Here also it comes to the HTTP. HTTP probe slash correct. Initial delay seconds 10. Okay. And success failure is 5 seconds. Am I giving any larger value? I think I have to give 5 seconds. Okay. Initial period second is 5. Success threshold is 5. Error threshold is 1. Turn validation of error. Okay, there are some errors are actually. This is correct. TCP liveness probe is correct. It comes as a part of your ports, correct? Ports, container ports, correct? Policy TCP liveness probe, HTTP get request, port 80 slash correct. No correct, sir. I think there is some mistake, sir. Guys, can you able to identify if there is any mistake here somewhere?
No, can you go to that terminal again?
Which terminal? Here, this one, huh?
That no, that another one. Can you fill on the output, right? Output coming, right?
Yeah. Okay. Error validating HTTP probe, error validating data, validation errors, spec somewhere. Unknown field, initial delay second. It's saying unknown field, sir.
Yeah.
Unknown field means basically there is some spacing issues there. So this is aligned with this, that is correct. Spec name, HTTP port, liveness, two spaces, correct. Uh, no, there is some issues here actually. HTTP get is correct only. So this I know very well. This is correct only. This is not. Port two spaces. Okay, sir. Linus HTTP. Somewhere there's a small mistake, sir. Actually, in this YAML. This is correct. This is correct. Liveness port is also correct. It is aligned with the port. Fine. Then after that, you are having port 1, 2, 1. This is correct. Port 80 path correct. We'll see if this doesn't work out. I'll let you know in the next session. What is the error? I think it should work actually, but there's some spacing issues there here. Somewhere I'm missing it actually. Wait, sir, 1 second. Initial delay second. Spelling is correct. Initial delay second. Okay, sir. Sir, I'll do one thing, sir. I'll check and I'll let you know, sir. This one.
Okay.
What will happen, right? If you run this liveness probe, right? What it is doing, right? It keep checking, sir, when this particular port and this particular path is there or not. If the particular path is active, what is happening? This liveness probe will return a success actually, right? So in this case, if you're running this pod will never get failed. It will keep running unless and until your application which is running, if that breaks, right? Until that liveness probe will be returning the success. Once there is some issue with HTTP, image which is running, or if that application is having some issues, under that case, what happens if this port is not working, or if this port is not accepting any more requests, or if this path itself is not available, in that case, the liveness probe will fail, and in that, if the liveness probe will fail, then what is happening that your pod will also get failed actually. The pod will get terminated. But based on the restart policy, what will happen? It will try to restart it. But basically, as you know that whenever the HTTP gets failed, when it comes to when you're doing a HTTP request probe, right? You will see that actually what is happening is that you will see that because you implement the liveness probe, right? Here, what happened, right? The default restart policy mechanism will apply here. It means that the pod will get restarted again. If you have mentioned here readiness probe, so readiness probe also will check it out, but when it fails, actually readiness probe will make sure that what is happening, that the pod will never get restarted again. It will get to the field state. That's what. So we can implement both, sir, readiness probe or else liveness probe. But most commonly used is liveness probe itself. Okay. Fine, sir. This example I will check and I will let you know, sir. In the next session, I will tell you where I was wrong actually. Okay, sir. Now, okay, that is fine. Now, what is happening now, sir? Like the very important topic, what we have is not for the Helm, sir. Okay, the next topic is Helm. So hold a second, sir. Let me have some water. So now, next is a very important topic, sir. What we have is a Helm actually. Okay, basically, Helm is nothing but it's a package manager, sir. Helm is a but it's a package manager. Okay, and this Helm it came very recently, sir. Just a few years back only, the Helm came into it, and if you see the Helm is that, but it is a package manager in Kubernetes, sir. Right? See, if you take any operating system, sir, for example, if you take Ubuntu or if you take Red Hat, or if you take any CentOS, right? Every operating system, it has its own packaging mechanism. Like for example, this is my Ubuntu Linux, right? This is my Ubuntu Linux. I want to install any package, sir. Like I want to install any package. Suppose I want to install some curl package, or I want to install some Docker package or anything, right? What you will do basically, you will say apt install something, like I want to install some package, a tree package. So what I will do, basically I'll say sudo, first I'll say apt get update. I will run this command to just update the package. So these are all the package repositories what we have. And then what I will do, I'll say sudo apt get install. Suppose I want to install some package by name tree. If I execute this command, so what it is doing, right? Basically here it is trying to install the tree package, right? How APT is working, because APT is not, but this is the utility or this is a package manager which is used in our Ubuntu distribution. Okay, APT, because it falls under the Debian distribution. Debians always follow the APT apt method to install any package, right? So now what is happening over here, that whenever you want to install any package, suppose if you take, so so here what is happening, that whenever you are having a Ubuntu machine or Ubuntu server or Ubuntu operating system, you have a certain package manager, and the package manager there, it is nothing but it is a APT app package manager. So app will maintain everything, sir. Like for example, what it maintains. Suppose whenever you want to install any package, so you want to install the package or install the software or package, then use this app command. Like for example, here in this case, I'm using app install and specifying the tree. So what you're doing, you're installing the package. Now, how it is getting installed, what is happening basically, sir? This is a Ubuntu operating system of the server. Outside here you are having some kind of a Ubuntu repository you have. That we call it as a APT repository, sir. App repositories. Now, basically, what happened, whenever you're installing any package, what this operating system will do, it will try to connect to this app repository,
Hi,
and
sir.
from here, whatever the package is there, right? Yeah.
Sir, can you please increase the font, sir? They are available actually. It's 8 only. Very
Yeah,
small.
it only, yeah.
Sir. Home, sir.
Home, yeah.
Okay.
Not rotate. Where is it?
You select an that This one, sir. Yes.
Okay. Now, what is happening that you have an app repository. Whenever you're installing any package, no sir, it will try to connect to your app repository, and it will try to install the package, whatever the relevant package you require. Correct? Similarly, what is happening is that tomorrow, if you want to update or you want to upgrade the package, actually, same thing. What you will do that you will try to use the command something like, suppose you have a tree, and tree is having some version, or the 1.0 which is installed in your system, 1.0 version. Suppose tomorrow you got to know that there is some more new version, a higher version as upgrade as 2.0 has come. Now what you will do basically, you will just try to do a apt upgrade, specify the package name. So what it will do again, what the app utility or the app package manager will do, it will try to basically again connect to this repository, and if there is any higher package available for this tree, it will try to upgrade it. It means that basically once you run this command, so what it will do, you will get the 2.0 version of it. Right? Now again, what happened, right? After some time you said that I don't want to do it, I want to remove this package, don't want to do. So what you'll do basically, you can either do a apt remove the package, or else you can even do apt purge and specify. Both will uninstall the package, it will remove the package. So it is very easy to manage the package manager when it comes to the operating system, because you have a utility, right? The apt utility is provided along with the operating system, where you can install any software or uninstall it, upgrade it, roll back it, or else suppose some specific version only you want to install it, you can specify that particular version to install it. So I can do many operation by using the apt package. So this is in case of a Ubuntu operating system, right? Similarly, you have a Red Hat operating system. Similarly, you have a CentOS operating system. For the Red Hat, you know that nowadays we are using a, earlier we used to use a yum package, yum method to install the packages. Now you are using a dnf command. Dnf is used for the latest Red Hat distribution to install any package. Say, for example, I want to install the tree. I'll say dnf install tree. So what happened? The DNF will try to connect to its repository, that is a Red Hat RPM repository, and then we'll try to install it. Similarly, you have a CentOS. So this is nothing but the CentOS actually. This is a CentOS operating system, and this is your Red Hat actually, Red Hat distribution. So in CentOS, we basically use a yum command, yum install, or else you can even use a RPM method. So what you're doing here, that you can easily manage any kind of a package for upgrade or for downgrade or removal, or installing anything with the help of this package manager. Similarly, what happened, right? Whenever you want to install any application, whenever you want to install any application into a Kubernetes cluster, right? See, this is your Kubernetes cluster, sir. You are having a Kubernetes cluster. You know that we have a master and we have a worker nodes, correct? We have a master and we have worker nodes. This is a master. These are worker nodes, worker 1, worker 2, right? Again, it is font, right? So worker 1, and then here having a worker 2, right? Now what is happening, that you say, Rajesh, I want to install some application. Suppose you say that I want to install the WordPress. You say, I want to install the WordPress. So WordPress alone will not work, right? Along with the WordPress, you need some kind of a DB also. So MySQL DB. So what used to write earlier, what used to do earlier, basically how used to do earlier, you used to write a manifest file or the YAML file. So something like WordPress.yaml. You know very well that we used to write a YAML. So here what happened, that you used to choose some deployment method to do that in your YAML file. You know that we used to use a deployment method. Similarly, what is happening is that actually for the MySQL also you used to write some MySQL.yaml file or db.yaml, some name you'll use db.yaml as a name. Here also you will use the deployment type, you will use as a some type, you will use deployment type. Either it's a replication controller, or either you use the deployment, or either you use a replica set. You will be using some kind of a deployment method, right? And then what is happening that you know that always WordPress, it always required some kind of a DB to connect to it. Without a DB, the WordPress will not work. So basically what happened, right? Here you are writing an individual YAML files and then you used to apply it. Apply means you used to do first do a cube cutter, right? You use a kubectl like that you used to do, right? Kubectl apply -f db.yaml. So first you have to run this command to apply so that it will get deployed. And similarly, after that, you used to run kubectl apply -f wordpress.yaml. So we know very well we used to do earlier all these things, right? With the help of a deployment, and the services, or using some resources, we used to write the YAML file or the manifest file, and we used to apply so that these applications will be created as a pod over here, right? It will get created as a pod and it will be up and running, right? So this could be either get created in a only one node, worker node, or else it could get distributed between the worker node. So this we know very well. But here what happened, right? This becomes very cumbersome, sir, because you need to maintain a lot, right? You need to maintain a lot. Suppose assume that you say that Rajesh, this WordPress and the MySQL, right? It uses many resources like deployment. It uses the services. It uses some kind of a resource quota, right? Many of the resources it has to use to build this application, correct? Even for the DB also, it also uses some kind of a resource. It uses some kind of a mount point. It means that you need to create a PVC. That is one of the resources. You need to use some kind of a service like you are basically using some like a cluster IP. Okay, you are not using any node port or the load balancer. Here for the DB only use cluster IP. You need to use mounts and some limits you need to set. So you need to provide a lot of resources to this YAML file, and then finally you need to do a apply of that YAML file to make sure that this creates at a pod and it gives the service, right? Correct. So it is a lot of stuff you need to maintain as an end user, as a developer. I need to maintain a lot of things actually. Now the challenging here is that actually, suppose this is okay, this is fine, this is I'm deploying it. Suppose the same deployment, so assume that we are having a various different environments, you know, right? You are having a dev environment, you're having a dev environment. So this is the developer environment, dev environment, right? And this is nothing but your test environment or the QA environment. QA environment. I'm sorry, again the here is nothing but this is nothing but the prod environment or the or not prod, sorry, UAT environment. And you have one more environment, right? You have one more environment, also prod environment. Now, what will happen that you are having a different environment, sir. Now you say that Rajesh, I want to test this application, WordPress or MySQL. I want to test it in all this environment. But you know that whenever you want to, do the testing of the same application in all the environment, the constraints might be different. It means that actually, whatever these YAML files are there, no, sir, this WordPress and the DB YAML file, it can particularly you can actually run both this kubectl apply onto this developer environment just to verify whether whether WordPress is running and how the MySQL is running. Correct. Now, whereas a QA environment, he might here what is happening that you might be using only one set of replicas to do a testing, because as a developer you have deployed, you have developed this application, right? You might not require any kind of a replica set. You might need you are okay with only one replica set because you're not doing a full-fledged testing, correct? Whereas a QA engineer, he said that no, I want the 4 replica set. So what is his constraint is that actually he will say that, oh, okay, I want the same application, but I need 4 replicas actually, as well as I want to do a limit set actually. Limit set is what is what you say that actually the request, it means that I need a maximum of 2 core CPUs, 2 core CPU, okay, as well as I need a memory of 1 GB. But whereas here you don't want to have the request limits for 2 core and 1 GB of memory. You don't require it. You might hardly require 1 core in the developer environment, and just 500 MB of memory sufficient you to run your application. But what happened? The QA engineer, he needs it because you want to do a testing and all, right? He might need. So this resources and all will be vary from one environment to other environment, right? Do you agree with me, sir? This vary. The application is same, sir. WordPress or MySQL. But here what happens, the requirements are different. For the UAT, You might need more requirement. You might need more memory than what the QA engineers use, because you are doing a user accepted testing. You want to test it how much max resources no user requests for this particular application in the UAT. So you'll do all kind of a testing, and in the production, you know that it is not one instance. You might need some 16 replicas to be get executed. So here, what is happening is that the requirements are differing from one environment to other environment, right? So it means that suppose you say that Rajesh, I have developed this YAML file, okay, that same YAML file will get executed in all the different environment. No, because you need to do the changes inside your YAML file based on the requirement for that particular environments. You need to do a lot of changes into it. So here, what happened that manageability become very difficult, sir. You cannot manage so easily. It means that the same YAML file you cannot use it actually. You cannot use in a different home. Whether you might have built, a developer might have built for his particular developer environment, but the same YAML will not get executed in a different one, because each and every requirement has its own specification, it has its own requirement. So that will not work out. So to make this life easy, so that actually you can better manage any developer or any engineer, a Kubernetes engineer, he want to maintain, or he want to maintain all this, in a better way actually, then they will go with the Helm package actually. So now you understood, right, why exactly the Helm is used. So Helm basically, Helm is basically used to manage all these manifest files or YAML files, or we can call it as a applications very easily, sir. So what happens that you need to install the Helm, sir. So what happened that Helm is basically, it is like a package manager, like how we have a in Ubuntu or in Red Hat anything, right? We basically have some kind of a manager known as a APT package manager, M, or the DNF package manager, or else in CentOS it is M or RPM package manager, where you can easily manage any packages. So similarly, what is happening that in the Helm, in case of when it comes to Kubernetes, to manage in a better way. Say tomorrow, what will happen that you say that Rajesh, I want to deploy some applications. Actually, there are a lot of interdependency. Here you could see that in this case, WordPress is depend upon the MySQL. If the MySQL is not there, WordPress will not run at all. MySQL should be there. So there is a dependency also, right? So you say that Rajesh, I want to have a deployment where I want to even install the dependencies also. I need not to run manually kubectl apply -f df YAML and kubectl apply -f WordPress done. I need not to do all this manually. I want to maintain in such a way that with a single execution command, both this deployment should happen automatically. So in that case, they say that please go with the Helm actually. So Helm is a package manager in Kubernetes. Clear, sir? Till here? You understood the crux of why we need a Helm actually? Now here what is happening is that suppose you have WordPress you have installed, and you have installed the MySQL also, and WordPress you might be using something like a 3.0 version, and the MySQL you might be using some 7.5.7 version. Okay, in all these worker nodes you have deployed the WordPress and MySQL of this specific version. Tomorrow there's a requirement come that okay, hey man, you want to upgrade your WordPress from 3.0 to 3.2. Okay, hey, you have to update your MySQL from 5.7 to 5.9. You know that whenever I want to update these applications which are running as a pod within the worker node, what you have to do, you have to opt for some kind of a rolling update mechanism. Correct. So the requirement comes from the client that instead of 3.0, you want to upgrade to 3.2, and for the MySQL, you want to upgrade from 5.7 to 5.9. So it is a cumbersome. It means that it is really painstaking to do all kind of an update to it. But assume that if you have made this as a complete package, WordPress and MySQL as a complete package, okay, and you integrate with your Helm actually, and if you integrate with your Helm, using the Helm, it is very easy to update, downgrade, or anything like how we are doing here, sir. Package. In case of a package, how I'm doing, I can install the package, I can upgrade the package, as well as I can remove the package. The same stuff, even it is applicable even in the Helm also. Helm also, using Helm, with a single Helm command, you can install both this WordPress as well as MySQL in a single shot. And tomorrow, if the requirement comes to upgrade, you can upgrade. The tomorrow, again, if somebody asks you to roll back or downgrade, you can downgrade. If suppose you don't want to do it, you can even uninstall or you can even remove all this complete package. So this, we bind it as a complete package, sir. And this package, we call it as a Helm package, or we can call it as a Helm chart actually, or we call it as a Helm chart. Okay, sir. Till here, are you okay, guys? You understood the idea or requirement behind why we need a Helm actually? See, there might be a chance where in your industry or in your organization they might not be using package Helm at all. You'll say that, Rajesh, why I want to get involved in this? I have my all my YAML files. I will maintain my deployment through YAML file only. Why I need a separate Helm itself to do that? But why we are having a Helm? Because that Helm is basically used to easily manage the deployment part. It means that even though suppose this they were having some three YAML files are there, all the three YAMLs are interdependent. You need not to explicitly deploy one after the other. You can make it as a single package, and which we call as a Helm chart, and you apply that Helm chart so that the Helm will take care of installing all those three YAML files in an easy manner, and to maintain it becomes very easy. And you saw that the advantage of using Helm is that actually, if you're having a different environment, right, then what is happening is that actually you can easily maintain the requirement of each and every environment by with the help of a Helm. You say that, so suppose here what is happening is that if you package together the WordPress and the MySQL in case of Helm, so what you will use right here in this case what you will do that for the dev environment, you will say that, okay boss, I want to install the Helm, so I have made the package as a like WordPress DB, something like you have together you have made it as a Helm actually with the name as a WordPress DB, something like that. If you install it, what is happening that by default what happened, whatever the basic or whatever the default value is there, with that it get deployed into this dev environment. Now you say that, okay Rajesh, I want to install the same stuff, but I want 4 replicas actually. So in that case, what will happen that actually here the same thing, the same command, I'm just giving you an example. Helm install WordPress DB. Here -FN set replicas 4 like this. So it means that inside your Helm, inside your YAML file and all, you need not to specify any, you need not to specify any kind of a replica set, right? Similarly, what is happening that you said, okay, Rajesh, by default, my package, Helm package, actually it is supporting for the service known as a load balancer. It is supporting for the load balancer. It means that whenever this by default get deployed, you will get the service of a load balancer. Tomorrow you will say that, Rajesh, I don't want the load balancer, I want the node port. This is load balancer. But you will say that, Rajesh, I don't, while deploying the same WordPress in case of a QA, I don't want the load balancer to be deployed as a service. I want the node port as a service. Then in that case, same thing. In the command line while installing itself, it is very easy to manage. Helm install WordPress DB. Same thing, sir. -FN set. Okay. Service something dot type. Instead of using load balancer, I want node port like this. So what is happening is that you can easily manage the same deployment in each and every different environment with the help of Helm actually. So this is one of the use case. It means that suppose anybody asks you, even though you are not using Helm in your organization, still it is always better to make all your YAML files to integrate within Helm within a Helm as a chart, because like you can easily manage it in the future. In the future, right, when you start working heavily on many of the different movements, you will not manually run this kubectl -apply -f and all. This becomes very very difficult to manage. It is not one of we are just talking here about one or two packages. There are hundreds of packages are there which you have to install in the production. In that case, will you execute the kubectl apply -f 100 times? It is very difficult to manage. In that case, what is happening that with the help of Helm, you can easily manage, you can easily configure, and you what based on that particular environment, you can actually pass some kind of a values or settings you can do, right? So that is the advantage of being a Helm, sir, actually. Clear, sir? Till here?
Yes, sir.
So now I'll take few more minutes, sir. Then we will wind up because already we have to. But we will continue this Helm in the next session. Okay. So now what exactly the Helm do actually? So I need to install the Helm package. Okay. I draw one more diagram here. So what I will do, like this is my Kubernetes, sir. Actually, this is my Kubernetes cluster. So here you know that in this Kubernetes cluster, inside it I have a master and I have a worker node. Correct. So this is nothing but your master, and this is nothing but the worker node one, worker one. And you know very well within your master, you are having a something known as the API server. So we've been reading from the day one, right? What is an API server, right? API server is the main core of your master, right? Which through which the communication happens, right? And the API server is the one which talks to many other different subsystem of your of your Kubernetes architecture, right? There are many different subsystems are there, right? So for all those like Q controller, right? And you have HCD database, right? Many of the components are there, right? API itself will communicate, right? Now what is happening is that here in the master, you need to install the WordPress application and the DB application like that. So to do that, actually, what you will do basically first you will install the Helm client actually. You will install the Helm client or the Helm package will install. So basically, what I will do that what you will do there are many versions are there, but the latest version is the Helm version 3 that we will be installing. Okay, this is nothing but the Helm client we say, right? And here what is happening that here you have something on the Helm registry. This is architecture I'm trying Helm registry. Like like for the Kubernetes, for the Docker, you have a Docker registry, right? Where what happened, all the images are placed, right? You know that hub.docker.com, right? So whenever you want to pull any image, I'll say Docker pull image, right? Or Docker, if you run any container, what happened that automatically, if that image is not present in your Docker cache, right, it will try to pull from the hub, right? And hub is not, but it is a public registry, right? So similarly, what happened, you have a Helm registry. In the Helm registry, what happened, right? You have a lot of Helm charts actually. So all the packaging of everything in case of Helm are maintained by the charts. So charts are nothing but it is a packaging format of Helm. So suppose assume that tomorrow you say that Rajesh, for deploying an application for the Jenkins application, what I do, you have to write a YAML file. You know very well, right? Suppose you say that Rajesh, I want to deploy some Jenkins here, or I want to install a Tomcat. You say, hey, go ahead, write the YAML file for the Tomcat, man, right? You know how to write. For the Nginx, we know, right, how we used to write, right? See, for the Nginx, how you write it. Like, for example, if you go for the deployment, where is the deployment, sir? Here? Controllers, right? See, if you go for the deployment, you know very well, right, how I used to write. I want to install Nginx. See, you have to basically write a deployment, right? And you need to use the Nginx, like Nginx image, you have to use it, right? So here, what happened? You are writing a complete YAML file for that, right? So it means that you need to know how to write a YAML file, what are the spec, what are this template, what are the selectors, everything you should know here, right? You should basically learn the art of writing a YAML file to deploy any application, correct? So I'm installing Nginx. But whereas here, what is happening is that in case of a Helm registry, this is a kind of a public repository, sir. What will happen that here you will have an Nginx chart itself actually. Please understand, sir. You have an Nginx chart or template we say basically. Okay. Similarly, you have a for Jenkins also you have the same stuff. You have a Jenkins chart or Jenkins kind of a repository. Similarly, for some kind of a DB, like for example, you need to have a Redis or MariaDB, right? MariaDB, see MariaDB, MariaDB. Also, you have a chart. So basically, what is happening is that here what is happening here that whenever a user say that okay Rajesh, I want some kind of a Jenkins to be deployed in my master and worker node, but I don't want to write any YAML file. So what happened, right? You have installed the Helm client or the Helm utility within your Kubernetes, Now what happened, right? You are actually requesting through the Helm that, okay, please install the Tomcat. So what the Helm will do, Helm will try to communicate with your API server, and Helm will check within my Helm register or repository, is there any chart actually. See, chart, what is chart basically? I will write it down here. Charts are nothing but packaging format of Helm for Helm actually. Okay. Now, what is this? Nothing but this Jenkins chart or nothing but it is a collection of charts are nothing but collections of YAML file .yaml file put into a folder. So you have something like a directory, or you have something like a tar file. Inside the tar file, you have all those charts. Actually, you have all those YAML files put together inside it, and you create a name, and that we call as something like a chart actually. So like that in case of a Docker registry, you have a images, collection of images will be there, right? Whenever you say, Rajesh, I want to deploy an Nginx container. So what you'll do, you'll say Docker pull Nginx. Whenever you want something like Apache, you say Docker pull Apache, right? So you can run any kind of an application with help of an image, and all those images are placed in your Docker hub. So it means that it's been registered as a Docker, public repository. Similarly, for the Helm, to maintain it very easily. So whenever you want tomorrow you want to run any application, or you want to deploy any application in your Kubernetes cluster, you need not to write a YAML file. Already somebody has written a YAML file as a YAML file, and he has integrated in the Helm as a chart actually. You need to just pull the chart and install the chart into your Kubernetes, so that that application will get installed in your Kubernetes cluster. That is what it is, simple, sir. Clear? Got it?
Yes,
And
right.
and we know that each and every chart, it has some kind of a releases, sir. Actually, you have something release. We will see more on this, what is release and all. Like whenever you installing any package, right, the package will come along with the release, sir. It means that whatever the updation you are doing to that package, right, always there will be some kind of a release tag is get attached. So we have something known as a releases actually. We have something known as a release actually. So what is a release means? A release is an instance of a chart running into the Kubernetes cluster. Suppose you say that, Rajesh, I want to install the Jenkins actually. So with the help of a Helm, what happened, right? The Helm will try to check into the Helm registry. Okay, there is something like Jenkins. Yes, there is hey, pull this Jenkins chart and install it here. Now when the Jenkins will start running over here in your Kubernetes cluster, so Jenkins would be running over here. Jenkins should be running over here. It has a release version of 1.0. Right, sir? Tomorrow you say that, Rajesh, whatever the Jenkins version is which is running, I want to upgrade it, sir. Okay, fine, no problem. What do you do that? You'll just do a something Helm upgrade and you specify your Jenkins start actually. So what happened, right? Again, what the Helm will do, Helm client will do, will check into the Helm repository. Whatever the user is requesting to upgrade, is that upgraded Jenkins is there? It is there. Pull and install it. Now what happened? The release will change from 1.2 to 2.0, 1.0 to 2.0. Now the release will change from 1.2 to 2.0, right? So this release has been updated from 1.2 to 2. So what is happening that for every release, right? For every release, what is happening is that actually it will maintain the release version, sir. So because why we is maintaining it is a change between, it's a change between one to other, sir. Tomorrow if you say that, Rajesh, I want to go back to the 1.0 only once, you can only specify the release number 1.0. It'll take back to your older version of the Jenkins, right? This Jenkins might be something like 3.7, and with the help of a release 2.0, you have installed 3.9. Tomorrow you say that 3.9 is not working, I want to go back to 3.7. You can just roll back using something like Helm rollback, specify the release name, it will go back to here. So it means that it is very easy to maintain even the rollbacking also, updating, rollbacking, downgrading, removing the package, or removing the application from the complete Kubernetes. Everything you can monitor very easily with the help of the Helm. So this is what it's, sir. Helm will make the life easy for any Kubernetes administrator or the developers, and it is very, very useful. But it is not mandatory that every industry is using Helm. No, it is not mandatory. So many companies are there where they're not even got into the Helm, but still they are running the show because like they are maintaining everything with the help of a YAML itself, right? They'll give the every YAML file to their customer itself, or into the real time they will be deploying the YAML file. They might not be maintaining to the Helm actually. So this is where you can showcase yourself that you know extra thing. That means that actually you are well versed with the process also. You are well versed with how you can manage the application in a better form with the help of a Helm. You can explain it very well to a interviewer. That's what Helm is very much important. And now slowly many of the industries have started moving into Helm now. Very easy managing of all the package or deployment with the help of a Helm. Actually, it's just like a one-line command, sir. If you execute it, it'll work. It'll nicely it'll get deployed. It
That is,
clear, sir?
yeah, clear. One small doubt, no, something called templates, right? In company,
Yeah, yeah, yeah. This charts are not, but it's a templates are actually. So what is happening is that actually here, what is happening is that actually here, based on the specific requirements of each and every environment, right? You want to do some changes to your YAML file. This YAML file, whatever the YAML file you have now, sir, this YAML file, when it comes to Helm, right, it will be called as a template only. Got it? So whatever the YAML file you have, right? Like for example, here you have a YAML file. You will be integrating this YAML file, db.yaml, wordpress.yaml. Inside the Helm, it is called as a templates actually. So, so what you will do that templates are nothing but it is like a skeleton form where what is happening that based on the template, you can actually pass some values to make sure that that get applied to that specific environment. So what is the template? I am supposed to tell you, but I will tell you in the next session, sir. What is template?
Okay, Rajesh. Got it.
Are nothing but YAML itself. So all the YAMLs are bundled together and they called as templates. You can create your own templates, sir, a user-defined template, or you can even create some kind of a skeleton template and later apply some values into it, everything like that. You can manage it very easily. So this we have to see in the next sessions and all, like how to create your own template, user-defined template, or else the existing template only we have to use. So whatever the changes which you are applying to the different environment, like as I gave an example, right, you will be applying with the help of templates actually. Okay. So that's all, sir, today for the day about the Helm actually, and we will continue in the next session about the Helm. How you have a lot of commands, sir. You have to first see how to install the Helm. After that, you have a series of commands you need to learn. Plus, you can even deploy any kind of applications, everything with the help of a Helm, rather than writing a YAML and doing a kubectl hyphen apply hyphen f, right? That we are not doing everything in Helm. It is very easy. So this is the next step of managing all your deployments, sir. Help.
Okay, Rajesh. Got it.
Okay, sir. That's all for the day. Okay. Anything is there? Let me know, or else we will stop the session.
Yes.
Okay, we can stop the recording.